Are you a cloud architect or a solution architect and you want to learn how to design a multi-cloud architecture or critical high security architectures? If so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects. And we're an organization that's dedicated toward building high-performance cloud computing careers. Personally, I've been working in technology for over 25 years, and I've been helping others get their first tech jobs or get promoted in tech for 2 decades. And when my students call me and say, I got cloud hired and I got my first cloud architect job, it makes me incredibly happy. Today, we're going to talk about multi-cloud architectures because realistically speaking, every cloud architect or solution architect really needs to be a multi-cloud architect, and every organization should be using a multi-cloud strategy or a hybrid cloud strategy. No one should ever use a single cloud. See, a single cloud is a single point of failure, and when we talk about this high availability, high security cloud architecture, we can't use a single cloud. See, here's the thing. I'll cover the 3 main problems that can occur with a single cloud. There's 3 major things that can occur in a single cloud where if any of these occur, the entire cloud can be down, regardless of the number of availability zones and regions you may use. And we've seen in the last 60 days, between October and December, there have been 4 major cloud outages, and they've affected more than one availability zone or region in many cases. So we can see the strategy of a single cloud and multiple availability zones does not work, and it's been proven many times in the last 2 months. But we've told people forever this can't work. So why not? You've got a single network. If the network were to fail, the whole cloud fails. We network architects design a network across 2 network providers. Never one, and we've never done it for the last 30 years. For that reason, we can't use a single network provider. 2, there's an orchestration part of the cloud called the control plane that makes everything work. If that breaks down for whatever reason, a hacking event, a misconfiguration, or just a bug, it can take the whole cloud down, which means every customer that's only using a single cloud can be down, not secure, and not available. Now let's talk about the 3rd potential thing that could go wrong. The cloud could get hacked in a massive denial of service attack, and it could take the whole cloud down, which means the cloud and all of its customers are down. So, as you can see, for these 3 reasons, a single cloud is a single point of failure, and you should always think multi-cloud architecture, because multi-cloud architecture or hybrid cloud architectures are the only high availability cloud architecture. So let's walk through our design here. In this particular design, we need 5 nines availability. So look at this base architecture we're going to give you. We're going to use 2 cloud providers, and we're going to have our own data center that's also going to be running an OpenStack cloud. So we have a hybrid cloud and a multi-cloud. No single points of failure here. So when you see we have the customer site, notice the following. We have 2 routers connecting to cloud provider A, 2 of them. Now these routers are going to be high availability routers, multiple control modules, which is the main brain, multiple power supplies, which are going to be plugged into different circuits, which are going to be plugged into different UPSs and different generators for backup power. So we've got redundancy in our power, redundancy in the brains of the routers. And you know what? We're probably going to use multiple links to create a link aggregation group and put them on multiple cards in each router. So you can see we've got redundant routers because we want high availability routers, so we want more than one of them, but we also want each router to be a high availability device. So we've got 2 connections to cloud provider A, and as you can see, we've got 2 routers. Those same high availability routers are going to be connected to cloud provider B, and we're going to run eBGP between them. So that's our basic architecture, 3 clouds, but in order to do this effectively, we've got to be careful with our IP addressing scheme. So we want to be careful to use a specific range, specifically a specific CIDR range for each site. As you can see here at the customer site, we've chosen the 10.0.0.0/16. Cloud provider A, we've chosen 172.16.0.0/16. Cloud provider B, we're running 172.17.0.0/16. So we've got, basically speaking, 3/16s that we're going to use. Now, one last thing I want you to see for this base architecture. Because cloud provider A only has the 172.16 CIDR range, that's all our site should ever receive. So between cloud provider A, they should only advertise that one subnet, that 172.16.0.0, which is the aggregate route or the summary range. And on the customer site, we're all going to have an access control list or a firewall that's going to only allow those subnets in from the top provider. And that way, if the top provider were getting hacked or our VPC were to get hacked because somebody came in through potentially an internet gateway, got on our systems, they can't get into our customer site. Now we're going to do the same thing with cloud provider B. We know cloud provider B only needs to send us the 172.17.0.0/16. We're going to take in their routes, and that's it. We're going to limit it to everything else. We'll filter routes to just that, and we'll also have a firewall or an access control list policy only accepting traffic. So now we've got basically 2 connections to each cloud, at least, because we're more than that because we're using link aggregation groups. We're using multiple service providers to get there. Our routers have multiple brains, multiple power, and multiple cards on them. So there's no single points of failure in our connections. Now let's talk about the security. And we're going to have some fun with this cloud security. Now this cloud security architecture is going to be extremely robust. So it's not for everybody. This cloud security architecture is going to be for people that have absolute mission critical security requirements that need absolute high availability. And it's going to be an expensive architecture, but for an organization that's got $1 billion of intellectual property, they have no choice. They've got to use something like this. So let's talk about this high availability cloud architecture. Now here, we're going to have 4 components of our security architecture. Now this is a really, really robust security architecture. And what we're going to do is we are going to use common security services across both clouds. And we have to do this across clouds, and even for the most part, we're going to use something very similar in our data center. And that way, we've got a single security policy we can deploy on everything. We know that all of our security devices are from the same type, the same brand, the same manufacturer, so we know what bugs we're going to get, and we're not going to deal with vendor interoperability problems, or this cloud only does this, and this cloud only does this. So we're going to use industry standards for everything. Now, by using industry standards, we're going to get much better security and much better performance. Here's the reason. The cloud providers all have their own services, and they're great services, don't think they're not. But Cisco's been making firewalls for close to 30 years. Check Point's been making firewalls for close to 30 years. Palo Alto makes security appliances for a long time, and that's all they do. And Fortinet only focuses on security. So if we have the opportunity of a cloud native service or an organization that only does security, we typically speaking are going to get a much more robust feature set of the organizations that whole business is security over the cloud native features. So we're going to get better security, and it's going to be interoperable. So let's talk about how this architecture would be laid out. Generally speaking, we're going to be dealing with web apps. So we want to protect our web apps from DDoS. So the best thing that we can do to really make our web applications scale and give us some protection is to use a content delivery network. So we're going to have on each cloud our own content delivery network. We're going to do this because content delivery networks, for the most part, only forward legitimate requests to the server. So they're going to block all the illegitimate requests. And if we're getting a bunch of requests at the same time for something, and we're using a content delivery network, if it's cached, it'll be able to send it. So it's going to offload our servers. We're definitely going to use a content delivery network. We're going to use some type of DDoS protection, whether it's Cloudflare's DDoS protection, whether it's Shield on AWS or Azure's DDoS protection. It doesn't matter. We can use the vendor's content delivery network, and we can use their DDoS protection. Now, that's where we start getting outside of vendor services, because that we're going to use the cloud's content delivery network. Next, we need firewalls. Now, if we use an industrial grade firewall, say a Cisco firewall or a Palo Alto firewall, we can have the same feature sets and functionality across all clouds in our data center. So we're going to do that. Now, unfortunately, you can't knock on the door at AWS, go to a rack, and screw in your high availability firewalls from Palo Alto or Cisco. You can't do it because we can't go to the AWS data centers. So what happens is when we want really enterprise grade, really robust security appliances, we have to get them from the marketplace, which means no matter which cloud we're on, these amazingly high performance firewalls and security appliances are going to reside on a virtual machine. So if it sits on an Azure virtual machine, a Compute Engine instance in Google, or an EC2 instance in AWS, it doesn't matter. It's on a virtual machine. But virtual machines are not high availability devices. So if we need one firewall, and it's not a high availability firewall, it's an EC2 instance or a virtual machine, we need redundancy. So that means, going back to our adage of 1 is none, 2 is 1, and 3 is greater than 2, we need a minimum of 2 firewalls, ideally 3. So let's say we launch 2 firewalls from the marketplace. They're not high availability devices, so we're going to need to load balance between them. So what we need to do is we need either a network load balancer, which is what we typically use. AWS has something called the gateway load balancer, and we're going to set up 2 virtual enterprise firewalls, and we're going to use a load balancer to load balance between them. The point of the load balancer specifically is redundancy, because a load balancer increases performance and availability by enabling you to share the load across multiple devices. So we'll have our content delivery network, we'll have our network load balancer that's going to load balance across our firewalls. Now the firewall is like this big giant wall around the house that keeps bad guys and bad actors out. But what if somebody or something were to get over the fence, this big wall? Well, we need something to stop it. That's typically speaking an intrusion detection and intrusion prevention system. But note, we're using a Palo Alto firewall, which is a next generation firewall. So that's going to have that intrusion detection and prevention built right in. So if we're going to hopefully block them with the CDN if it's DDoS related. If not, we're going to block them with our firewalls. And if for some reason the bad actor sneaks past our firewalls, hopefully our next generation firewall uses IDS, IPS functionality and creates a new rule, resets the TCP connection or whatever it does, and thwarts the attack. But you know, when it comes to security, it's like an onion. Keep peeling back the layers. So let's add some access control lists to protect our subnets. So whether it's an AWS network access control list or an access control list on a router, use that. So now they got to bypass our CDN, they got to pass our load balancers, our firewalls, our IDS, IPS capabilities, and now our network access list. But we're not done. This is still moderate security. We're going to go for extreme security. So with most cloud providers, you have the ability to secure your virtual machines. AWS has something called the security group. All the cloud providers do. So the next thing we're going to do is we're going to protect our servers with security groups, which are basically a firewall on the way in, and they're typically stateful. So now we've got to get past the CDN, we've got to get past our firewalls, our IDS, IPS systems, our network access control list, and our security groups. We're still not secure. Now let's talk about the servers we're going to use. You know, we should put another firewall on those servers, like a host-based firewall. We definitely need to put some anti-malware protection. We need to patch the servers against known vulnerabilities, but that's not enough. We really want to disable the unnecessary services on these things. We want to harden our systems and lock them down. So now let's look at our systems. You've got to bypass the CDN, the firewalls, the IDS, the network access control list, the security groups, the host-based firewalls, and now you've got a lockdown hardened system. But that's part of it. So let's talk about the other things. Now we're going to talk about access control and best practices. So what is identity and access management? Because it's a critical component. Identity and access management determines who a user is, what they're allowed to do, and it keeps track of it. Now the reality is creation of users and management of users, especially at scale, it's going to get really complicated. So most organizations are getting something like Microsoft Active Directory, and we feel that's a great thing to do. So we'll use Microsoft Active Directory, and whether we're on AWS, we'll use something like AD Connector. If it's Azure, we'll use something like Azure AD, but we definitely need a strong identity and access management protocol to keep bad actors out and allow people to use only what they're supposed to, nothing more, and then track it. Now, with any of the cloud providers or any data center in general, if you were to run a protocol analyzer or a sniffer and you'd find the traffic on your systems, it might scare you. And what happens is people just put stuff up and it may or may not adhere to a security policy. So ideally, your engineering team or your DevOps engineering team that's going to build some things can template known good configurations and only deploy the known good ones. So a service like AWS Config is really great for this, only allowing an organization to only deploy what you've approved that meets the security standards. Now, we should secure our data at rest. Now, typically speaking, the best thing to use is just AES 256-bit encryption. With AWS, for example, we enable the key management system. On Azure, for example, it's automatic. But we want to encrypt our data. Now, we've done a lot. We've got a lot of robust security for our VPC, a lot of robust security for our data centers. We're tracking users. We're only allowing no good systems, and we're encrypting. But what happens when somebody comes in and they try some social engineering to the receptionist and they ask for a password? Or when they send some phishing emails and people click on it? We really need to train the employees of the organization. So part of any good cloud architecture, cloud security architecture, multi-cloud security architecture involves training. So you're going to bring in a team of training people. Now we've got something really robust right now, but we can make it better. So attacks happen, and the better your ability to monitor them and respond to them, the faster you can do so, the quicker you are to mitigate the attack or remediate the attack. Now, We love the concept of event-driven security, meaning if this happens, do something else. For example, somebody makes an object public in, say, object storage, like an S3 bucket, something that's not supposed to be public, it's supposed to be private. We can literally have a log notification, and we can have some type of a code function remediate it for us. So let's talk about it. I'll use AWS for the description, but it works on all cloud providers. With AWS, let's say we turn on cloud monitoring, CloudWatch, CloudTrail. We've got CloudWatch events, EventBridge, or whatever you want. Something that we see that we don't like, and it kicks off a Lambda function, and the Lambda function remediates it. So now, in addition to our super robust architecture that we have, we've got some really cool monitoring and some auto remediation. So now we're into next generation security. Things are going to be self-healing. But if we, as security architects, cloud architects, enterprise architects, and solution architects, as well as the security engineers, the cloud engineers, can see stuff that's going on in real time, they can make better decisions. And it's really hard. If any of you have ever looked at syslog logs and noticed that you get 1,000 logs per second, it's really hard to figure out what's going on in there. So what we can do is following. We can take all these logs, maybe some VPC flow logs, maybe some CloudWatch logs, what have you. And we can stream this as streaming intelligent information. And we can put it into something like Apache Kafka, Amazon Kinesis, for example, and we can stream that data. And then we could take that stream data and put it into a visualization tool like Tableau or QuickSight. And we can literally see what's going on with our traffic. We can watch what's going on and determine if we're getting hacked. So by putting these things together, by using multiple tools, we can secure systems, make them much higher availability. What's the secret to using this? It's using industry standard tools. Kafka versus Kinesis, a marketplace firewall versus a WAF. In any case, by using interoperable things and multi-clouds, we can build the highest security, highest availability, high performance cloud architecture. So we always recommend a multi-cloud architecture. For years, we've recommended multi-cloud architectures and hybrid cloud architectures because a single cloud is a single point of failure. If you're a cloud architect and you want to design high availability systems for your customers, you must use more than one cloud, more than one network provider. And if you want to make them really high secure, you're going to have to use some generic, industry standard, really high-powered security tools that are going to work across multiple cloud providers. This is Michael Gibbs. I'm a multi-cloud architect, enterprise architect, and network architect, and I have been forever, and I think cloud architect jobs are some of the best in the world, and that's why I'm here talking about cloud computing and cloud architect jobs for you. I look forward to seeing you in another video very soon. Take care. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I've known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architect.